Good evening. Today, first we will solve few examples on parametric equations of circle, and then I'm going to explain the concept of tangency. That is an important concept. Exercise 6.3. Write the parametric equations of the circles. First equation, x square plus y square equal to 9. Compare it with x square plus y square equal to a square. So a square is 9. So a is plus 3 because a is radius. Now what are the parametric equations? X equal to a cos theta. See, we have done this in trigonometry also. X is cos theta, y is sin theta. But in that case, it was unit circle, means radius was unity, that is 1. Here radius is a, so x is a cos theta, that is 3 cos theta in this case. And what is y? Y is nothing but 3 sin theta. Okay, so these are the parametric equations. Second, circle equation is given in general form, x square plus y square plus 2x minus 4y minus 4 equal to 0. We have to write this equation in which form? Center radius. Let me explain. Consider terms in x. X square plus 2x. This can be square of x plus 1 only. Why? Why x plus 1? Working rule is simple. When you square, it is always 2 times the product. So divide coefficient of x by 2. So 2 upon 2, that is 1. Now tell me what is x plus 1 square? X square present plus 2x present plus 1. We have added 1, so subtract 1. Y square minus 4y can be square of y minus 2. Check that. Y square minus 4y plus 4. So subtract 4. Then why this minus 4 again? Because it is present from the beginning only. Minus 4. Okay. So x plus 1 square plus y minus 2 square equal to minus 1 minus 4 means minus 9 becomes plus 9 when goes to right hand side. Now compare this with x minus h square plus y minus k square equal to r square. That gives me h equal to minus 1, k equal to 2 and radius equal to 3. Now what are the parametric equations? X minus h is r cos theta. So x is h plus r cos theta. That is minus 1 plus 3 cos theta. What about y? K plus r sin theta. That is 2 plus 3 sin theta. Right now. Third is for homework. I will give the answer for that. Second sum, find the parametric representation of circle 3x square plus 3y square minus 4x plus 6y minus 4 equal to 0. Actually, it is similar to second part of first sum. The only change is coefficient of x square and y square is not 1. It is 3. So just divide by 3. That's it. I have explained different method here. See, this is equation of circle in general form. So compare with x square plus y square plus 2gx plus 2fy plus c equal to 0 to get values of g, f and c. So what is center minus g minus f? 2 by 3 minus 1 and radius 5 by 3. So you can say this is h, this is k and this is r. So what is the answer? Parametric equations are x equal to h plus r cos theta and y equal to k plus r sin theta. Okay. Or you can say that consider terms in x. So x square minus 4x by 3. This can be perfect square of x minus 2 by 3. See, x minus 2 by 3. So that method can also be used. In exam, any correct method will be given full credit. Okay. Right now. Now we are going to discuss an important part, that is tangency. Though we are interested in tangent to circle, we will consider tangency in general, that is tangent to any curve. So I will not use the word circle. I will say tangent to a curve. Okay. Now how a tangent is defined? Tangent is defined as the limiting position of secant. How will you prove that a line is tangent to any curve? The logic is simple. If that line is intersecting the curve in two coincident points. See, is this the tangent? No. But if this line intersects the curve in two coincident points as this, then it is nothing but tangent to this curve. If you consider circle, is this line tangent? No. But is this line tangent to the circle? Yes, it is. Okay. So this is about tangent. So tangent is the limiting position of secant. And this is called as point of tangency or point of contact. So in tangency, we are basically considering 4 points. Number one, equation of tangent to the curve at a point on the curve. Actually, when I say equation of tangent, I need not say at a point on the curve. Why? Because when I say tangent means point has to lie on the curve. Means what? Suppose this is the curve. See, if the point lies inside the curve, no tangent can be drawn. If point lies outside the curve, you will notice, see, this point lies outside the curve. So this is one tangent and this is other tangent. Okay. But if point lies on the curve, see, this is the point, then only one tangent can be drawn. So when I say equation of tangent, by that I mean equation of tangent to the curve at a point, say x1, y1 on the curve. Is that clear? So this is the first part which we'll be discussing for any curve. Secondly, we will find the condition. We will find the condition that line with slope m is tangent to the curve. Means what? Suppose this is the curve. Now there are infinitely many lines having the slope m. All of them will not be tangent to the curve. Equation of any line with slope m can be taken as y equal to mx plus c. So I am interested in knowing what is the restriction, what is the condition on C so that line with slope m will be tangent to the curve. So out of many lines having slope m, it can be seen that this line is tangent to the curve. So restriction will not be on m. Slope will be given. Restriction will be on C. So in second part, we will find the condition that line y equal to mx plus c is tangent to the curve. In third part, we will show that in general, listen to me carefully. In the third part, we will show that in general, these two words are important. In general, two tangents can be drawn to the curve from a point x1, y1 in the same plane. I repeat this statement. In the third part, we show that in general, two tangents can be drawn to the curve from a point x1, y1 in the same plane. For that, clearly, we have to obtain a quadratic equation in M where M is slope. Now it's a quadratic equation. So there are three possibilities. Roots are real and distinct. Means two distinct tangents can be drawn from a point in the same plane. Consider this particular curve, which is clearly a circle. Yes, two distinct tangents can be drawn from this point because the roots of quadratic equation in M are real and distinct. Second possibility, delta, that is discriminant, is 0. So only one tangent can be drawn. Clearly point has to lie on the curve. What is the third possibility? Discriminant less than 0. So no real tangent can be drawn. Clearly point has to lie inside the curve. If you consider this curve, it has to lie inside the curve. Is that clear? So we are using the words in general. In the third part, we will show that in general, two tangents can be drawn to the curve from a point x1, y1 in the same plane. Right? Fourth part is important and interesting. we will find locus of points. We will find locus of points, tangents from which to the curve. Locus of points, tangents from which to the curve are at right angles. Now we have already obtained quadratic equation in M. The slopes M1, M2, I'm sorry, the roots M1, M2 of this quadratic equation are what? Slopes of the two tangents. Now if tangents are perpendicular, M1, M2 has to be -1. But M1, M2 is again product of roots, which is constant term upon coefficient of M square. See, the topic is geometry, but you should know all points regarding quadratic equation. You should know theory of quadratics. Is that clear? So in the fourth part, we will obtain equation of locus, tangents from which to the curve are at right angles. For example, this is circle. Now these tangents are at right angles. So locus of all such points. Tomorrow maybe we will be proving that locus of points is again a circle in this case. Means what? Consider any point on that circle. If you draw tangents from that point to this circle, inner circle, then they will be definitely perpendicular to each other. Is that clear? So I repeat these 4 points. In the first part, obtain equation of tangent to the curve at a point on the curve. In the second part, we find the condition that line with slope m, say y equal to mx plus c, may be tangent to the curve. So restriction will be on c, means for which value of c or which values of c. Why? See, for this circle, for actually this diagram is not correct, because when I say slope is same, I must draw parallel tangents. Yes, see, for one value of m there are two tangents which can be drawn. Is that clear? So the restriction is on c, for which value of c or for which values of c line with slope m will be tangent to the curve, that we discuss in the second part. In the third part, we show that in general, two tangents can be drawn to the curve from a point in the same plane. Now, why to say in general? Actually, we will be getting a quadratic equation in M, where M is slope of the tangent. So all depends on nature of roots. If roots are real and distinct, means yes, two distinct tangents can be drawn. If roots are real and equal, only one tangent can be drawn. If roots are imaginary, no real tangent can be drawn. Use common sense. Point has to lie inside the curve. Then only it is not possible to draw a tangent. Now, in the fourth part, if two tangents can be drawn, they can be parallel also. I'm not saying they must be, they can be parallel also. So we are interested in all such, I'm sorry, not parallel, perpendicular. In fourth part, we are interested in finding locus of points, tangents from which to the curve are at right angles. Okay, so this is about 4 parts which are applicable to any curve. Before we discuss these 4 parts for circle, because the topic which we are discussing is circle, let me tell you an interesting notation. It is called as S notation, capital S. Let me explain that. Now we write equation of any curve with right hand side equal to 0, and we say that, for example, now I will consider one particular curve, say circle. What is equation of standard circle? X square plus y square equal to a square. We write this as x square plus y square minus a square equal to 0. Is that clear? Yes. Now, the expression on left hand side. What is the expression on left hand side here? X square plus y square minus a square. We denote it by s. I'll tell you from the beginning. Write equation of a curve with right hand side equal to 0. left hand side, this is not an equation on LHS, this is expression. This expression is denoted by S, capital S. Now expression obtained from S, how? By replacing x by x1 and y by y1 is denoted by S1. I repeat, S1 is expression obtained from S only. How? By replacing x by x1 and y by y1. So can you tell me what is S1 for this particular circle? Simple one. X1 square plus y1 square minus a square. Is that clear? Now third part is interesting. An expression obtained from S only, from this original. How? Replacing x square by xx1. X square by what? Xx1. Y square by yy1. 2x, actually 2x means what? X plus x. So 2x by x plus x1. 2y is actually y plus y. So 2y is to be replaced by what? Y plus y1. Keeping constant term unchanged is denoted by what? T. Now you will ask me, sir, what is the significance of this? I'm going to tell you that only. What is the significance? Capital S equal to 0 represents the curve. Do you agree with me? You have to see capital S equal to 0 is what? X square plus y square minus a square equal to 0. Yes, it represents the curve. Simple. Secondly, what does S1 equal to 0 represent? S1 equal to 0 means point x1 y1 lies on the curve, lies on curve. This is common sense. X1 square plus y1 square minus a square equal to 0. S1 equal to 0 means what? X1 square plus y1 square equal to a square. When this happens when x1 y1 lies on the curve. So s equal to 0 represents curve. S1 equal to 0 means x1 y1 lies on the curve. Third part is important. This is important from CET point of view. T equal to 0. This is interesting. T equal to 0 is equation of tangent. That is why T. Equation of tangent to curve. Equation of tangent to curve at x1, y1 on the curve on it. This means for the circle, x square plus y square equal to a square. What is equation of tangent by observation? Replace x square by xx1, y square by yy1. That's it. Keep constant term unchanged. Right? So just by observation, you can say that what is equation of tangent to x square plus y square equal to a square? It is xx1 plus yy1 equal to a square. In fact, we are going to prove this result just after few minutes. Okay, so this is about S notation. Using this notation, let us find equation of tangent to circle x square plus y square plus 2gx plus 2fy plus c equal to 0 at a point x1 y1 on it. We have to use T notation. Logic is simple. So what is tangent? Can you tell me tangent? It is x into x1 plus what is y square? Y1. Now next part is interesting. This is g into, because we have decided that 2 into x, 2x is to be replaced by x plus x1. So g into 2x will change to g into x plus x1 plus 2fy is basically f into 2y, but we have decided that 2y will change to y plus y1, constant term as it is. Yes, this is equation of tangent to this circle at x1 y1 on it. Is that clear? Okay. We haven't done parabola yet, but I have already told you equation of parabola. It is y square equal to 4ax. Can you tell me equation of tangent to this parabola at x1, y1 on it? Type your answer in chat box. Yes, I write this as y square equal to 2a into 2x. How to get equation of tangent? Replace y square by y1, 2x by x plus x1. Keep constant term as it is. So this is equation of tangent to parabola at a point x1, y1 on the parabola. Now we discuss tangency in case of circle. So again 4 points we are going to discuss, of course one by one. First part, equation of tangent to circle at a point x1 y1 on the circle. We are going to consider two circles. This is standard circle and second one is general circle. In the second part, we will find the condition that line y equal to mx plus c may be tangent to this standard circle only. In that case, we will not consider general circle. If you want to apply it to general circle, you will have to reduce that equation in this form by shift of origin and so on. Okay. In the third part, we will show that in general, two tangents can be drawn to circle from a point x1, y1 in the same plane. And finally, we will obtain locus of points, tangents from which to this circle are at right angles. Is that clear? Okay. Now, what about circle x square plus y square equal to a square? Its center is at origin. And what is radius? Radius is nothing but a. Okay. So, this is nothing but a. Now, tangent is drawn at which point? x1, y1. We are interested in equation of this tangent. To get the equation of line, we must know two things. One point on the line, yes, it is known, and slope of the line. At present, we do not know slope of the line, but we do know that radius through point of contact, P is point of contact, radius through point of contact is perpendicular to tangent. Can you tell me what is slope of OP? y2 minus y1, that is y1 minus 0 upon x2 minus x1, that is x1 minus 0. So this is slope OP. So slope of tangent is what? It is minus x1 upon y1. Do you agree with me? Why? Product of slopes of two perpendicular lines is minus 1. This tangent is perpendicular to radius. Slope of radius is this. Its negative reciprocal is slope of tangent. Okay. Now we know one point on the tangent. So by point slope form, equation of tangent is y minus y1 equal to slope minus x1 upon y1 into x minus x1. Rearrange the terms, multiply by y1. So y1 minus y1 square is minus xx1 plus x1 square. Rearrange the terms. So I get xx1 plus yy1 equal to x1 square plus y1 square. But note that x1, y1 lies on the circle. So coordinates will satisfy the equation. So x1 square plus y1 square can be replaced by what? By a square. And therefore, what is equation of tangent? Xx1 plus y1 equal to a square. We have already obtained this using which notation? Capital S, S notation. T equal to 0 is the equation of tangent. What is that T? Expression obtained by replacing x square by xx1, y square by yy1, keeping constant term unchanged is T. Yes, xx1 plus yy1 equal to a square. I hope you understood this. In exam, you are not supposed to mention S notation or T notation because it is not included in the syllabus. But I have just told you so that result can be remembered easily and it is applicable to any curve. Okay. Now the point x1, y1 can be a cos theta and a sin theta also. Why? Because these are parametric equations. So the tangent is drawn at a cos theta and a sin theta. So it will be the equation. It will be x into a cos theta plus y into a sin theta equal to a square. Rearrange the terms, that is divide by a to get x cos theta plus y sin theta equal to a. This is equation of tangent to the standard circle at which point? This point is represented by p of theta. We have discussed this. At a point p of theta on the circle. I hope you understood this. After this, we have to consider general circle. What is that? X square plus y square plus 2gx plus 2fy plus c equal to 0. We will be using same logic. We will be finding slope of radius. Its negative reciprocal is slope of tangent. Now point from which tangent is drawn is known. So by point slope form, we get the equation of tangent. Let me explain. The equation of tangent to the circle x square plus y square plus 2gx plus 2fy plus c equal to 0 at the point p x1 y1 on it. Now what is the center of this circle? C minus g minus f, right? Suppose p x1 y1 be the point on the circle at which tangent is drawn. What is slope of CP? y2 minus y1 upon x2 minus x1. So y1 plus f upon x1 plus g. Now, radius through point of contact is perpendicular to tangent. So, slope of tangent is what? Negative reciprocal of this. So, minus x1 plus g upon y1 plus f. Now, slope of the tangent is known. One point on the tangent is known. So, by point slope form, equation of tangent becomes y minus y1 equal to minus in bracket x1 plus g upon y1 plus f into x minus x1. Cross multiply to get this. Open all the brackets, rearrange the terms. How? Xx1 plus yy1 plus gx plus fy equal to what? X1 square plus y1 square plus gx1 plus fy1. Now this step is interesting and important. Add gx1 plus fy1 plus c to both sides. Now you may ask me, sir, why? Because we get an equation in simple form and the logic t equal to 0 works here. That is why. So if you add gx1 plus fy1 plus c to both sides, you get what? Xx1 plus yy1. Now gx is already there. As gx1 is added, take g common to get x plus x1. Fy is already there. To it fy1 is added. Take f common to get y plus y1 plus c plus c. Now RHS becomes x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. Why? Because gx1 plus fy1 plus c is added to right hand side also. So this is right hand side. But note that x1 y1 lies on the circle. So x1 square plus y1 square plus 2gx1 plus 2fy1 plus c equal to 0. Yes, this is the equation of tangent. And you will notice that it is in accordance with that notation, t notation. Replace x square by xx1, y square by yy1, 2x by x plus x1, 2y by y plus y1. Keep constant term unchanged. That is why it is xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c equal to 0. Note that this is standard result. In exam, you need not prove this. You can directly say that tangent to general circle is this. For the given circle, g equal to f equal to c equal to, tangent is drawn at x1 y1. So equation of tangent is that clear? Now write down. Give the title tangent in bracket S, tangent or tangents to circle. Write down. Equation of tangent, number one, equation of tangent to standard circle, equation of tangent to standard circle, x square plus y square equal to a square, x square plus y square equal to a square at p x1 y1, at p, point is p, at p x1 y1 on it, at p x1 y1 on it is, right now, xx1 plus yy1 equal to a square. See on the slate, xx1 plus yy1 equal to a square. Next line, tangent at p of theta is, right now, x cos theta plus y sin theta equal to a. X cos theta plus y sin theta equal to a. Equation of tangent, equation of tangent to the circle, equation of tangent to the circle x square plus y square plus 2gx plus 2fy plus c equal to 0. I repeat this equation, x square plus y square plus 2gx plus 2fy plus c equal to 0 at a point p x1 y1 on it, at a point p x1 y1 on it is, right now, xx1 plus yy1 plus g into x plus x1 f into y plus y1 plus c equal to 0. Now exercise 6.3, sum number 3. Find the equation of tangent to the circle x square plus y square minus 3x plus 2y equal to 0 at the origin. Now the equation of tangent to this circle is known. So just compare. G is minus 3 by 2, f is 1, c is 0. Now substitute the values. That's it. Tangent is drawn at x1, y1, which is origin, that is 0, 0. So what is the equation of tangent? X into 0 plus y into 0 minus g, that is minus 3 by 2, x plus, in fact, plus g into x plus x1, but g is minus 3 by 2, simple, into x plus 0 plus f, which is 1, into y plus 0 equal to 0. On simplification, 3x minus 2y equal to 0 is the equation of tangent. Now last sum, fourth one, show that the line 7x minus 3y minus 1 equal to 0 touches the circle x square plus y square plus 5x minus 7y plus 4 equal to 0 at the point 1, 2. I am going to explain two methods. In the first method, we will obtain equation of tangent to this circle at 1, 2. And it must be what? 7x minus 3y minus 1 equal to 0. So for that, I have written for this g equal to 5 by 2, f minus 7 by 2, c4, tangent at x1, y1, that is 1, 2. On simplification, yes, I am getting the same. So line is definitely tangent to given circle at which point? 1, 2. Right now. Now second method can be show that length of perpendicular from center of the given circle to given line. Don't declare that it is tangent. We say it is given line. But if that length of perpendicular is the same as the radius of the circle, means what? That line is definitely tangent to the circle. So that method is also correct. This is the given circle. Suppose this is the given line. I have drawn it as, I have shown this as tangent. Actually, we have to prove that. So find out length of perpendicular from C on the given line. If this comes out to be radius, it clearly shows that line is tangent. That's it for today.